today we're going to demonstrate a technique to find the functional asymptotes of rational functions by long division. And actually I'm just going to demonstrate a technique of long division of a rational function, but it is to find the functional asymptote. That's why I'm doing it. So we have x squared minus 1 over 2x plus 4. The first thing I want to do to this function is I want to factor out a 2 from the denominator. I want to rewrite it as 2 times x plus 2. Now I want to move the 1/2 out in front of the expression and give x squared minus 1 over x plus 2. And now I have a choice. I can either distribute the negative 1/2 through the numerator, or I can leave it out until the end. I'm going to, and then once I do the long division, multiply the result by 1/2. I'm going to go ahead and multiply the numerator by 1/2. So I'm going to get 1/2 x squared minus 1/2 in the numerator over x plus 2. Now I'm ready to long divide. So we put 1/2 x squared, and I'm going to put a place saver minus 0x because there's no x term, plus 0x. Doesn't necessarily really even make a difference. Minus 1/2, and then I'm going to divide it by x plus 2. So now I need to know, what do I need to multiply x by to get 1/2 x squared? Well, that would be 1/2 x. So then I multiply 1/2 x times x, and I get 1/2 x squared. I multiply 1/2 x times 2, and I get x. Now I subtract. These cancel. I get negative x. I go through the same process. What do I have to multiply x by to get negative x? Well, that's negative 1. I multiply negative 1 times x. I get negative x. Negative 1 times positive 2 is negative 2. Now when I subtract, it changes these negatives to positives. And I'm bringing this down as well. And now these cancel, and I get 3/2. I can no longer multiply x into 3/2. Divide x into 3/2. So I'm left with y equals 1/2 x minus 1 plus the remainder 3/2 over x plus 2. And that's actually this function, or f of x rather, since I called it f of x, it should be consistent. F of x equals their equivalent expressions. This in fact is the functional asymptote. Just this part is the functional asymptote of the function. So if I was to graph this, I would have a functional asymptote of 1/2 x minus 1. If I wanted to see if this function crossed the asymptote, I could do one of two things. I could set the asymptote equal to the function and solve for x. If I get a true statement, x equals 1, if I then, or what, etc., then it will cross the asymptote. F will cross the asymptote at that x value. If I get an untrue statement, say 0 equals -5, then it never crosses the asymptote. Or I can take the remainder and I can set it equal to 0, and I multiply both sides by x plus 2. I'm left with the untrue statement, 3/2 equals 0, which is of course not true, so therefore I never crosses the asymptote.